And hello, welcome to our second race result webinar this evening. For those of you who don't know me, my name is Elliot. I'm part of the support team here at Race Result headquarters in Germany. Alongside me this evening is Thorsten, our head of IT, responsible for the firmware on the decoder. So he's going to be on our chat answering some of the questions you might have for us. So please do send us your questions, engage with us, and wish him happy birthday because it's his birthday tomorrow. Sorry. So before I start, I just want to say a huge thank you to everyone who's watched our first webinar. That was looking at raw data mode in Race Result 11. We had some really good feedback, and it's been great to hear people have said they've watched it and they've started converting to raw data mode. So thank you to everyone, and hopefully today is just as interesting and useful for everybody who's watching. So today we are looking at our decoder here. In particular, we're going to be looking at the firmware. We understand some people may have questions about the hardware side of things, but we ask you save those for another time. You can email them to us on our support@raceresult.com email, because today really is focusing on the firmware. And the reason for that is we release regular updates to the firmware on our decoders. In fact, in the last 12 months, we've had 10 updates in total. And those have been sometimes bug fixes, just small issues we've had, but also have brought a number of good improvements to the firmware. Some new features and some new modes that you may not realize are there or you may not fully understand yet. So today we're going to be focusing on the new features. We'll touch on some of the basics as well, just in case you're not 100% familiar. But yeah, so like I said, if you've got any questions, send them in and we'll either answer them on the chat, or if Thorsten or anyone thinks I've missed anything, we'll try and answer it here on the video. So here I have our decoder, you can see next to me. I've got it in passive mode for now. We're going to start on passive. We're actually going to start on some of the decoder system settings that are universal for any timing mode. We'll also look at the active side of things and then the browser interface of the decoder as well. So I'm going to open up our menu to begin with. You should all be familiar with this. There are eight menus, sub-menus in here. We're going to start out just looking at timing. So we have a few options for timing. Running time for if you'd want to have it continuously running. Start time, so you can set it to a set start time, and when you activate timing, it will start from that time. And the most commonly used mode is GPS time, of course. I personally recommend this for pretty much any race scenario. GPS time gives you the most accurate time across all your devices, and you have a fixed reference point. So if you do have an issue, sync its GPS time, it's going to be the same. Now, one of the new features we introduced with GPS time is that if it couldn't get a good GPS lock, it would take maybe a few minutes before the decoder would say, hey, I've not got GPS signal, what shall I do? Now, after 60 seconds, it will actually give the option to take an approximate time. So inside the decoder is a timekeeping module, which has an approximate time at all times. Now, if I actually exit the menu here, you'll see there's an asterisk next to my time. This means I'm using an approximate time because I'm inside the office, as you can see, so I wasn't able to get a good GPS lock. So this is an approximate time, but as you can see, it's pretty accurate. You'll probably lose a few seconds turning it off and on again. So back in the menu, I'm just going to go to configure GPS time. So in here we have the time zone, which is pretty self-explanatory, and leap seconds. We get asked about this pretty much every time we go into the menu. So it's important to understand that the main time reference is UTC time. But when we sync to the GPS time, it doesn't automatically take this into account. So rather than us trying to wait for the signal to say, here's the leap seconds, we decided the best way was that if we set a default setting on the decoder, which would be automatically applied then. So as and when the council of time, or whatever you want to call them, updates the leap seconds and says we need to add more, we will update the firmware so the default setting is correct. It's important to note that not every timing hardware, every piece of timing hardware will calculate leap seconds in the same way. So if you are using your race result decoder alongside something else, you should check the leap seconds value on that if they don't account for it, and you can manually adjust this value to match what it needs to be. So that's our timing, and I'm going to move down to our upload settings. We'll come back to network in a bit. There is something I want to show you there. So our basic upload settings have your customer ID, the SIM pin if you need it for your SIM card, the connection type, which has either Ethernet, automatic 2G, 3G SIM card, or manual. So You'll see when I switch to manual 2G, 3G, it reminds me to configure my settings in the web browser. And we will come to the web browser a little bit later. I can enable it, and then we have our upload target. So you'll see here we have HTTP and TCP upload targets. So HTTP was when we were using the transponder module. And if you're using your own timing software or another third-party software that does connect to our servers, you're using the HTTP upload. TCP upload is for the new time module. This allows for greater communication between the system and our network, so you can monitor it a lot more closely. Now, we do recommend that as the time module is still in beta mode, you keep HTTP and TCP enabled. If you aren't using the time module at all, you could choose to switch to HTTP only. This will save a little bit of your data allowance, but the difference is minuscule. We're talking megabytes of data per event. So TCP is test only currently, and there we have both. Now you see with TCP enabled, we have the option for current and non-archive files. We'll come to the archiving in a bit, and this means any files that are considered current and active in the device. And we'll get to where those are set in a little bit. So moving on, we have trigger impulses. So if you're using raw data mode, you may have seen the options for markers. And also in the settings, you can start your event based on a marker time. And this is essentially a time that is sent to the software by the decoder, which says this is just a timestamp. It's used for something other than a time normally a start time. You can also use it for things like photocells, light barriers, and tape switches, so you can assign that and match that to a chip code to give you a really accurate time. Now, we do this now by the default called a marker. Now, we used to set it at decoder level where it would try to match a chip code to a marker, but that had a few issues if people were close together. So now we just send a marker and a chip code at all times. You can set the marker number. So here I've set it to 99,999. So I know that whenever I see that code in my software, it's a marker and it's something other than timing. If you do have 99,999 people in your race, not only do you probably have a world record, but you can change it to whatever you need it to be. You'll see it can also increase the marker number. So this is useful if you want a marker for different waves, and you can increase it as time goes on with each press, and I'll show you that in a second, so that you have different markers for each start. So let's just go and have a quick look at how these work. So exit the menu, I'm going to activate timing here. So you see that as I press my green start button, it now shows the marker on the screen. And I'm just going to quickly switch to a race that I have set up temporarily. And I've already connected to this device in the time module, and you can see we have one read. And below here, you can see the time, and actually in race.11 says a marker. We already identified this is a marker from the decoder. Now, how can I use this? In start times finish limit, it helps if I actually switch to the right window. Here are all our markers listed. So in races.11, all you'd have to do is simply copy and paste that into your start time, and there you have it. That's pretty much the most accurate start time you can get. Switching back to our decoder, there it is. If I press it again, I've not got my count going up, so it will go to 99999 again. So if we enable this next time round, there it is. It's gone up to 100,000 with the next two presses because it started from 99999 again and increased. So that's useful, like I said, if you've got different waves and you want to make sure you can distinguish between these in your software. So back into our menu, we'll have a quick look at the system settings. And here's one of my favorite settings that makes my life so much easier as a timer. So on startup, you can choose what you want your decoder to do. So the default when you receive your decoder is it's going to do nothing. It will turn on and you'll have the menu and it won't be running time, it won't be activated timing. It's set as it is. You can now set it to automatically set GPS time. You can set GPS time and activate timing here. And you can also set it to set GPS time, activate timing, and enable upload, all when you turn the decoder on. This is really useful for remote time points because you can just give your system to an assistant. They go out, they turn it on the course, and straight away it's got everything set that you need. We've all been there, we've all forgotten to press that start button to activate timing and had to go find the emergency files. So this just takes that step out and you can't forget to do it. So I talked about archiving files. So we can archive any files that are currently in the device through this menu in 2. Reset all settings, I think, is pretty self-explanatory. And online firmware. So currently we're in firmware version 2.22. So if you're not already updated, just connect your decoder via LAN connection. I've got mine here. You'll probably need to enable your DHCP in your network settings to get an IP address automatically from your router. Simply hit OK and it will search to see if there is a more recent version of the firmware. It will say, do you want to install it? Hit yes and away you go. I do recommend doing this on a fixed internet connection, such as a router at your home or your office. Mobile connections can do it, but if these slow down, the download can hang and then you'll have to restart the process again. So finally, by scrolling down, you'll see an option to upload diagnostics data. Now, sometimes if there is a problem with your system, we may ask you to send the diagnostics. This allows us to have a better look at what's actually happened and what's gone on with your decoder so we can try and fix it if there is a problem. Again, all you need to do here is connect your decoder via LAN port and hit OK to upload diagnostics. I'm going to give a quick word. There may be a warning on your decoder when it boots up saying a crash was detected and send us your diagnostics data. This is a warning saying something may have happened that was wrong with your decoder. It does not mean there is a problem with your decoder, but this message will keep occurring until you send us the diagnostics. We would rather know every small problem so that we can fix it if there is a problem, rather than just ignore it, forget about it, it didn't happen again, 6 months down the line it's a problem. We want to know about it as soon as possible. So if you do see that warning, send us the diagnostics and the message will disappear. So that's our main system settings, and info just shows info about the device. Here's our device ID, current firmware, the active firmware version, which does receive some updates over time as well, and the internal temperature. So now let's actually look at some of the timing settings, the important things. So this is one thing a lot of new users have trouble understanding, is dead time and reaction time. So these settings here, 5,000 milliseconds and 850 milliseconds, are the default. In testing, we found these were the optimal values to get the most accurate reads without also overloading the software. So what are they? So reaction time is the time after detecting a chip that the decoder waits for a stronger detection before saving the chip read. Stay with me here. I will explain this a little bit more in a minute. Dead time is the time after a chip read for which the decoder will ignore the chip. So even if that chip comes back into the field, we won't get any more chip reads for it for the duration of the dead time, by default 5 seconds. Switching back to our decoder. Now, how are these applied, and what do we really mean when we're using these? So we have detection modes. So you'll see now there is a mode called first and last detection. This was released a few versions ago in the firmware, and it was brought about to increase the chance of a start read for a participant after the gun start. And I will explain the issues we were facing before. The other issues you had are last detection only, our legacy format, which takes the detection every dead time milliseconds, and first detection only. So those are the 4 modes we have. The main ones you really need to worry about are first and last detection, and understand the legacy format. So to help me understand these a little bit better, I have prepared a little graph. So when a chip enters the field of the antenna, it's read sometimes hundreds of times a second. And we want the time where the chip is directly over the antenna. This is going to be where the signal strength is strongest, right? But unfortunately, it's not a nice linear curve. We can't just say, here's the strongest read and take that one only. Here's an example of how that curve may look. You'll see there's peaks and there's dips in the signal strength. So RSSI is the signal strength. And here it is over time. This could be anywhere from a second to 2 seconds in this graph. So I'm going to identify these peaks in the data. These are obviously where the signal strength is strongest, and we're going to use these to calculate the actual chip read time. So here we have reaction time. So like I said, reaction time is the time between each detection the decoder waits before saving the chip read. So in this case, we have the reaction time set to 850 milliseconds. So you'll see the gap here was 750 milliseconds. There was no stronger peak after that, so we're going to take this read as our peak. Now, if our reaction time was only 500 milliseconds, it's only half a second, we'd actually end up with this read here, which, as you can see, is unlikely to be when they were directly over the mat, but they were pretty close to it. So that's our reaction time, and we will wait 850 milliseconds each time until we get the strongest read, and after that, we will send the chip read to the software. So here's our read. And dead time applies after that. So after this chip read, the decoder will wait 5,000 milliseconds by default before another chip read is recorded for that unique chip. Not across chips, just that unique chip. So where's the issue? So if we have someone right on the start line, and here's our T0, our start time, then you'll see that the chip read is just before that, and we're not going to have a start time for that participant. So how do we fix it? We go to first and last. And I think Dawson's going to hand me a question. Passive only. I got that, don't worry. That's covering the active side. So first and last is pretty much what it says on the tin. It's important to know that first and last looks at the chip for the entire duration that it is in the field of the antenna. So here we have the same graph with exactly the same peaks and exactly the same dips. Let's highlight the important peaks again. You might notice the difference here already. Reaction time works in exactly the same way. Of course, this hasn't changed. We still want the time when that chip is directly over the antenna as our first detection. There it is. And we're also going to take a read on the last peak. So this is the last peak which we saw that participant as they were in the field, which is probably the very moment they step over the mat, and we're going to get one last detection from them. So how is that useful? On a start line, the dead time applies from that point in this case. Okay, so 5,000 milliseconds will apply from your last peak, not your first. So here we have our T0 again, our start time, our gun time, whatever you want to call it. Now, if we just had the legacy format, we wouldn't have the start time for them. But by using the first and last detection, we have a start read for this participant. Now, this isn't the best example because we've only got them over a very short period of time. So let's look at this in a slightly more realistic example. Here you can see we've got quite a few more peaks and dips in our signal strength. Now, this is probably someone who was stood on the mat right at the start line. They were brought forward before the start. They're getting read hundreds of times a second. Just click on the right screen, Elliot. Here's our first detection. Again, you can see here, this is probably 850 milliseconds within that. So here's our first peak. There's nothing else within 850 milliseconds after that. So there's our first read. We're then going to have about a 3-second wait between the first detection and the T0. So here's our T0 that was set. So if we were using our legacy mode, we wouldn't have a chip read for this person after the gun time. So maybe this peak here, they were told on your marks, they lean forward over the mat. So we get a bit of a peak here. Then the race is started and we get a last detection for them just as they move out of that field. So here, this is the time we would take for the start time. Now, you could say, well, why don't I use the last detection mode and then switch to the first detection? You could, but if you forget to do that, your times on the finish line are going to be less accurate. On the start, you of course always want for the next time the last time you saw the participant, and for the finish, you want the first time you saw them. So that's where this really comes in and is a lot more helpful. I will say this won't solve the problem of people starting early. If you have a participant who jumps the gun by that split second and this last read is still before T0, unfortunately you won't have a read for them. Now you could set up other rules with raw data mode that say just take the last time of any time so you can see if they started or not. But if they jump the gun, I'm sorry, we can't fix that one. So I'm just going to quickly go back to the decoder. So hopefully now you understand the different detection modes we have and how the new mode is going to be helpful for your starts in particular without having to keep changing your settings. So also down here we have test mode. So you can either set test mode, and this is when timing is not activated, when you first turn it on if you don't enable timing. You can either react to all transponders, or if you have people walking to and fro and you want to test each antenna at a time, we sell a test transponder in our shop. This is coded as a test transponder. The decoder knows it's a test transponder, and you can tell it to only react to test transponders. So you can tell if each antenna is working based on this. So carrying on with our UHF settings, our passive timing. So in here we have a couple of settings that you may want to use. The first one is frequency. So this setting is only applicable to European decoders. You'll see that the frequency range for European decoders is pretty narrow, less than 2 megahertz difference between the highest and lowest values we can use here. In the US, you've got about a 20 megahertz range, so you don't have the same conflict when we're switching between frequencies within the permitted range. So if you're worrying that you don't see this in your decoder and you're from Australia or the US, don't worry, you don't need to worry about that setting anyway. For Europeans, there are options: auto, frequency A, there it is, and frequency B, hopefully, when we get to it. So how do these apply? Let's go and have a quick look. You probably already saw I was queued up for this. So if you just have a single time point, single device, single decoder, keep it on auto. It will then just switch between all the available frequencies, which I will note we actually have to do by law. We can't just leave it on a single frequency and scan the whole time. So we have to do that. But if you introduce a second system and keep it on auto, there is a chance that when the frequencies are too close together, they can actually cause interference, and you may get a dead zone in your detection. You'll note that we have a minimum of 3 meters here. This is recommended for all setups to avoid interference between the decoders in any way, shape or form. So in auto, you can see we may have that dead zone. You won't always, you will still get good reads, but if they get too close, they can interfere. So if you've got two systems that are on the same time point, set them to frequency A and frequency B. You'll see here that we don't have the same interference. You won't have the same amount of channel switching. It narrows the range on the two, but it will give you much better read rates. So if you're using two systems together and you're in Europe, make sure you remember that. Back to our menu. I'm going to put it back to auto. And the next one is power. Don't use the power setting unless you absolutely 100% have to. Power is a dangerous setting. If you apply permanently and you do not set your power back to maximum, you will have reduced read rates on your timing point. The power setting is there because there are some applications that it's useful. If you're at a big marathon with thousands of people picking up their bibs, you may have a chip check station where they can walk up and check their chip is reading and allocate it to their number correctly. Now, if this is on max and you're using side antennas or even sometimes the floor antennas, you can pick up every chip in that expo center randomly, and you don't want that. So in that case, you may want to adjust the power setting so you can just select people you need to actually read. You can choose to apply the settings permanently, or if you just exit the menu, it will only apply them for the time the decoder is turned on. When you turn it off and on again, these settings will reset. So that's our passive timing. So I'm now going to plug in an active extension. I have one prepared earlier. And you'll see now we have a nice warning. So this used to cause a few issues when people were plugging their active extension in and time mode was enabled in passive timing. Now we detect this correctly and we will stop timing and switch to active. And we'll give it a couple of seconds. Active extension plugged in, switch to active screen. Hit OK. And you'll see we have our active settings, our channel and our loop IDs, which I've got set to 1 and 1 at the moment. So let's go back into our menu. So let's have a quick look at detection again. You'll see that reaction time is no longer here. Reaction time does only apply, as was pointed out to me earlier, to passive timing. The way active systems work is that we will always get the chip read when the chip is in the middle of the loop where the signal strength is the strongest. We will only get that time where the signal strength on the chip is strongest, so you don't need reaction time. Dead time still applies in the same way. Now if we move over to our active extension,
which replaces our UHF settings, we have a few options in here, and there's actually quite a lot of settings when I scroll down. The first one is channel. So you can have up to 8 channels and 8 loop IDs as well. That gives you a maximum of 64 unique combinations at any one time. So setting your channel, hit OK, and if you're in time mode, it will ask you to stop timing mode. It will warn you it will be dead for a couple of seconds while it scans, and you'll get this. And you'll see on here, we've got the 8 channels with a percentage value. Now I'm in a nice quiet office where I don't have much interference on my Wi-Fi channels, so they're all at 100%. At an event, you may have interference from television cameras, even your PA system may use 2.4 gigahertz, and sometimes even just people having a lot of mobile phones nearby, all with their Wi-Fi left on, trying to scan for networks, can cause interference on the 2.4 gigahertz channel. So where possible, you should always use the strongest channel. That's where the percentage is the highest. Now, in some events, that may not be possible because you have a lot of time points, some being reused, so you reset the preset the channel and loop IDs. But where possible, try and use the best quality channel. I'm going to keep it on channel 1. And loop ID. So there are 8 loop IDs, like I said. It's important to know that if you are using a loop box on repeat mode or store mode, you should make sure your decoder or your USB time box in time mode is set to loop ID 1, which is the base. This says that this decoder will receive all the detections from other devices. If it's not set to the base, it won't try and listen for anything on the network. So loop ID 1 is receiving anything from loop boxes. Discarding stored detections. Now, if you're not using store mode in any loop boxes, you could set this to yes. There could be a chance you'll have old stored parsings if you had anything, or there may be some interference with your stored parsings. So your software may not handle these very well. So you can discard these at the decoder. It won't listen to them, won't record them, and you won't receive them. Most of the time, you probably want this to set yes. As you can see, I get a warning when enabling it. We'll just wait for the warning to disappear. It won't be saved permanently, as it says. And scrolling down gives me a few more settings. Processing. So processing is a slightly confusing one. This is how the decoder handles the data. We know that some third-party software expects chip reads in a logical order. Now, if you have repeat mode or store mode, the times may not be received in perfect sequence. So if the decoder only has readings from the decoder, it will just send them as soon as possible. If it detects another device on the network sending this data, it will try and put these in the correct sequence. That is smart processing. The other option, if you don't care and you just want that data as fast as possible because your software handles it, is set it to send it as fast as possible. As soon as it gets the chip read, it will send that data. You can also set it to wait at least X seconds, just in case you really want to make sure it's going to give you it in the correct order. I'm going to keep this one on smart. Beep on repeated parsings is what it says on the tin. I/O. So here I have another active extension. This one obviously isn't the one that's connected at the time. And you'll see on the top here is a 3.5mm jack, headphone jack. So we can actually use this in 2 ways. It can be used for audio out, beep out. So the same way the decoder beeps when it receives a parsing, you can send this through the headphone jack, through the active extension to headphones or a speaker. The other option is trigger in. So this is for our markers. So we talked about markers earlier, sending markers and timestamps to the software. If you have photo cells or tape switches, you can connect these into your 3.5mm headphone jack and set it to trigger in, and this will send a marker through the I/O port of the active extension. Channel switching. So in our V2 transponders, we introduced a backup channel. So if you didn't already know, the transponder actually sends its data over 2.4 gigahertz channel to the 2.4 gigahertz antenna on your active extension or loop box. It's not received by the loop. Now, there is a backup channel here. So if the transponder cannot send it on the channel you select, it will try and send on the backup channel. But this is only a feature of the V2 transponder. So if you have a V1 transponder, the decoder is constantly switching between the main and the backup channels, and there is a very slim chance it will not receive the data from the transponder
because it's on the backup channel at that precise millisecond. If you keep it on auto, as soon as the decoder detects the V1 transponder, and that's coded in, it knows which V1 transponders are, it's in the data there, it will switch channel switching off. So it says, I have V1 transponders, I don't want to switch my channels just in case. Now, if you are 100% confident you only have V2 transponders, you can force it to switch channels. Similarly, if you're only using V1 transponders, or you know you have some in the field, you can entirely switch it off, so you don't even have to let the decoder decide, it's switched off. But most of the time, keep it set to auto and you won't have any problems. It will automatically disable if it needs to, and you've got that backup channel for your V2 transponders if it needs to use it. So I think that's all of the settings on the decoder. Are there any questions that have come through on the chat that we haven't answered yet? Nope, I'm not getting anything. So we talked earlier briefly about the browser interface. So let's pull that up quickly. And in this window, I've already got it open. So all you need to do is open up your internet browser, and in your address bar, type in the IP address of your decoder, whether it's static or dynamic. Type it in, hit enter, and this page will load. The first thing you'll see is current parsing files. So these are all, like I said, the current parsing files which are considered active, the most recent ones. And if I click on one of these, here's all my data. So this was obviously me doing some testing in the office, because this is the system that sits at my desk. Here's all the data. It was just running on running time here. And there's the data. So if for any reason you can't get it through your transponder module or time module, or you need to go back to it, all your files are here. If you want, you can just right click, save link as, and save it as a TXT file, and you can then import that through the transponder module, and later on the time module. Archived files. Now, obviously we talked about archiving files that we don't need anymore. They're still saved on the decoder, so if you need to get to them, they are here, but they're compressed, and they won't be uploaded with TCP upload. So they're all there for you. Scrolling down, emergency text. Now, we've all been there. Like I said, we forgot to enable timing. So we now have an emergency text file, which is all the latest detections that were sent to the decoder when it was not in timing mode. And this has come in useful. I won't lie, been there. So the data is there, but don't rely on this, okay? You'll see the data format is weird. It's chip code and a time, or with the active, you get a little bit more data. We don't support reading this file. You need to work out this data to import it manually. It's literally just the quickest save of data. Our configuration settings, so we've already got our time zone settings in here as well if we need to. Our 2G, 3G, so remember when we switched to a manual APN settings, this is where you can come and configure those. Our upload target, again, we have HTTP, TCP, both custom HTTP if you want to send to your own server, and also race result TCP and custom HTTP. Now, there may be sometimes you want to send via TCP to your own server, or maybe a third-party tracking software. So down here in client mode, you can send that data to an external server, enter the server location online, the port number, and a timeout, the watchdog. You can enable it to start after boot. Now, you might be wondering how you can monitor this. If I quickly jump back into my decoder, like I said, I'm going to go back into the network settings here. You'll see now I've got one set there. I have the option for TCP client mode. This is only there if you've preset some TCP clients. Hit enter and you'll see the options and you'll see where it's sending this data. Of course, it can only send it if upload is enabled and you have an active connection, but that's where it is if you need to use it for custom uploads. Back to our browser interface. Standby down the bottom. We often get asked if standby is useful. No, is the very simple answer. This is designed for places where they have a permanent installation of their system. We have a few tracks around the world where the system is installed, people can come at any time or do their test runs, and the times are then sent to their server and calculated. Of course, they don't want this reading data throughout the night. So you can choose to turn the decoder off automatically at whatever time you want and turn it back on at, again, a preset time. I recommend, unless you're in that scenario, do not set this. Don't think, oh, turn it off just to make sure,
because if you have a race that runs past your standby time and you forget to disable this, you're going to be in for a pretty bad time. You're going to have to go out and turn it on manually and make sure you disable that. Our diagnostics, again, you can send your diagnostics through the browser module. You do need an internet connection, and it will take sometimes up to 10 minutes to do this, so you need to give it a little bit of time. Up in our top right corner here, show active systems. Now I hopefully have a loot box connected at the same time as well. I think I turned it on. Yep, there it is. So before the time module came along, or if you're not using Racer.11, the time module, here you can monitor your active systems that are connected to this decoder. So here's a loot box I've got connected on the same channel. There's no loop connected, so I'm getting an error. But here I can see some information about it, and it will refresh every 5 to 10 seconds or so. I can also set my time through here. So if I've got a system hardwired down somewhere and I forgot to start the time, I can either set it manually or set GPS time. I can also enable time mode through here. So there's some useful controls here as a backup and to check your system's connected. But all of these features are available in the decoder apart from TCP client. And I think that pretty much covers everything for the firmware. So hopefully now you have a better understanding of our decoder and some of its features and settings. If you do have any more questions,